One viewer. What's this guy's name spelled? Well, since we have one viewer, I figured I might as well get this party started. The premise and underlying concept to this was pretty much just to bring a bunch of people together and start doing a bunch of common network troubleshooting issues that people see day to day. If you don't know who I am, I will give you an introduction. My name is Rob. I've been in IT now for about 3 years. I started out as just a level 1 desktop technician, doing my everyday thing of making sure computers were up and running and all that other good stuff to go along with it. What I decided to do was I wanted to broaden my horizons. So obviously the next best thing to do would be to get in and start doing things in the network, such as networking and servers and stuff like that. And that piqued my interest. I got into it. Fortunately for me, the company I worked for, we brought consultants in all the time to jump in and start helping out and stuff like that. And that made me even more interested. So long story short, 3 years later, here I am. Currently, I'm a network infrastructure engineer for a large company in the Milwaukee area. Won't tell you who, but that's what I do. If you follow me on LinkedIn, that'll tell you everything you need to know. Beyond that, currently I hold a CCNP in routing and switching, a CCNA security, and VMware Certified Associate. So I do a bunch of different stuff with that. From a high-level overview, what I want to go over with on this right here is just to give you an idea as to what network troubleshooting can actually entail and how it'll actually work. So what I'm actually going to do is I'm going to flip screens on you, even though you've been watching here for a few minutes. And I'm going to bring up because my pen pad doesn't work on my other monitor. So what I'm going to do is I'm going to do full screen share on this guy and start screen share. All right. Whoa. You guys don't need to see that. All right. So you get to see what I've been playing with. Now what I'm going to do is I'm going to bring this guy up and bring this guy over. So that's what you guys need to be seeing. And from there, bring up this. Now I can see what you guys are seeing. All right, cool. So now that we have that, get this out of the way here. So what we have basically is your common network topology. So grab my pen pad here. So if you don't recognize this topology, you will quickly become used to seeing it on my YouTube channel. This is Internet Network Experts CCIE version 5. This is their topology for version 5 CCIE for route switch. So as a high-level overview, this is the topology I will use for the entire routing section, which is going to be pretty much all of what I put out there for anything that's routing. So it'll be routing. Routing. We'll have services. We'll throw in security, all that other good stuff. So we're going to have all of these different aspects into this one big topology, and I will also have, where'd my pen go? There it goes. I have GNS3 fired up and ready to roll whenever we decide to start kicking things off. And I also have my GNS3 topology here. This is how it's all physically cabled. So basically what I've done is I've taken a bunch of 7206 routers. I found 15.2 Advanced Enterprise Services online. I downloaded it, and I'm running that inside of GNS3. And I've got the 20 routers here. I understand you may not be able to support that, but to give you an idea of what I'm running for a server, I'm actually, it's a Dell server. It's got 24 gigs of RAM, 2 Xeon processors on board, so it's definitely more than capable of handling the workload that I'm going to be throwing at it. And as of right now, I'm barely using anything on it. I've got 10 routers running. I've had all 20 of them running for 2-3 days straight. Not a problem. For those of you that don't like GNS3 or would like another solution that's out there, you can actually run CSR 1000Vs. If you go to Cisco's website and you hunt down cloud services, you can actually run the CSR 1000V inside of ESXi, which I actually have running. Not currently, but it's something that I've deployed where I run it inside of Workstation here. And that's going to take a few minutes to pull up, but as you can see right here, I've got 1000V here. I got a bunch of ESXi stuff that I've installed here inside of VMware. I took ESXi and I installed it inside of VMware Workstation, and I'm able to use that as a virtualization. You know, it does the trick. But basically what I've got here is I've got all this stuff employed here. 5 fibers where it's running ESXi and CSR. I've got 6 routers deployed, but I'm not running them right now because it's 15.4 code, so it's the latest and greatest Cisco's put out. So, but what I really want to pay attention to here is actually the network and the troubleshooting aspects that come into play with it. So, from a high-level overview, one of the common things that I run into as a support engineer, or in previous positions, I should say, is a lot of how redistribution works. And I'm going to kind of focus that in as to what our core topic as we go through as to how things are going to work. But the big thing that a lot of people have a problem with is understanding how redistribution actually works. And whether it's they've never dealt with it before, or they see it in their network where like you might have EIGRP as your internal IGP, your internal gateway protocol, doing all your LAN routing, and then you have BGP as your external gateway protocol, you know, routing between your sites and stuff like that. So that's the most common thing that I run into. I don't know if redistribution is working correctly, and unless you understand what it is that iOS does from a software perspective, with how it goes out and finds what routes to apply and what routes it doesn't come to apply, a lot of this stuff can be kind of difficult for most people to grab. But since I've gone through a lot of the CCNP stuff and I've studied CCIE for quite a while now, a lot of this stuff is actually pretty straightforward. It's just understanding what's going on. And in my opinion, the more fundamental understanding you have, the better off you're going to be. Because I've known a lot of guys that are really good with a particular type of networking, whether it's going to be they're really good with security. You know, they can get on a firewall, they can write a policy, they can make this happen, they can tweak some policies, they can use application recognition like NBAR or App ID if you're using Palo Alto or something like that, and you can go in there and you can tweak your policies to be great. You know, you're letting only specific ports through, they're opened up when the application's in operation, they shut down when they're not, all that stuff is great. But from a grand scale, security is just a small piece of the puzzle. Because realistically, let's think about it. If we don't have basic route switch in play, then what good is security? A secure network is awesome, but if you don't have end-to-end reachability, who cares how secure it is? And that's just what my boss likes to throw out there. So one of the things I want to talk about is some of the things that people don't grab about security, or I'm sorry, redistribution. And from there, we're going to look at some of the different things you can do to, one, implement redistribution, and then we have remedy things in play that you can't get a route to propagate. Why? And stuff like that. So right now I don't have any routing protocols running. I have, and just to clarify what you see on your screen right here, DMVPN itself right here, this guy right here, is actually a replacement and an enhancement more or less than anything else. It is actually what they call an overlay tunnel. An overlay tunnel simply means it's going to use an underlying transport to get data from point A to point B. Simple as that. So DMVPN stands for Dynamic Multipoint VPN. DMVPN is just a routing capability. So VPN itself simply means virtual private network. There's two different types of virtual private networks. You have the secure IPsec point-to-point between two offices, maybe your headquarters in a branch, and then there's SSL, remote access VPNs. Doesn't always have to be SSL, but we have remote access. It could be PPTP. It could be what's another one that's out there? Point-to-point. I've only used that once, but those are different types of remote access VPNs. Those are the secure VPNs, meaning you're going to be able to send data from your local network to a remote site or to a remote teleworker, say a salesperson or somebody that's working from home, securely. And the data is going to be encrypted. So, and there's definitely a bunch of different ways of doing that, but that's not what we're going to talk about in this video. What we're actually going to take a look at, the other type of VPN is what they call a point-to-point. A point-to-point is going to be, well, actually there's point-to-point, there's point-to-multipoint. The difference between the two is point-to-point. This is going to be what the MPLS Layer 3 VPN is. And we're currently running that in my environment right now. We have 20 remote sites, and the idea behind the MPLS VPN, the way that it works, and I'm not going to get into like all the hardcore details of it, but let's just imagine that R5 here was a PE router, and that R10 is a CE router. Do you know the difference? Well, I'll save you the effort. This is provider edge, this is customer edge. This means this right here, from here to here, is all provider. So this is going to be your ISP, whether it's AT&T, Time Warner Cable, Level 3, Hurricane Electric. Doesn't make much of a difference who it is. Most of them provide the same services. So you're going to have a PE router right here. Then you're going to have, we're going to say R2 is a P router and R1 is a P router, and then we have R3. R3 is going to be a PE. And for the sake of argument, R7 is going to be a CE. Now, basically what happens is we have and actually this kind of ties into redistribution too, so I'll explain how routes get from point A to point B. What happens with R5 as a PE router is you're going to have the global routing table. I'll just put GRT here for short. Global routing table. This is where BGP is going to exist, and the internet routing table. This is what this guy uses to route is at. Then you're going to have, when it comes to separating customer traffic, it's what they call a VRF. A VRF stands for Virtual Routing and Forwarding Table. You create a VRF for every customer network that you have that you want to separate the traffic for. The idea behind this is you are able to take, say, customer A and customer B traffic, have them on the same subnets, so the 10 10.0/8, the 172.16/16, whatever the case might be, you can have them on the same subnet as some customer B, which can be running the same subnets as customer A, and they are logically separated. What VRFs do is they create another MAC address table and another layer 2 forwarding table, or the LFIB. The idea behind this is you're able to take routes from an interface you configure. So let's say gig 1.58 here is in, we'll say, VRF A, and you take, and this is what this guy is attached to, right? So, yeah, just for the sake of argument, I know it's not directly connected to it. It's actually R8 to R5, but, you know, just go with it. Basically what ends up happening is R5 receives routes in from R10. They take those routes from the VRF and they redistribute them into BGP. Now, from a perspective, the way that this actually works is R3 and R5 actually have a BGP, an I BGP tunnel. Now, how does that happen? How do you get routes from a VRF into BGP? Well, you redistribute. That is how you're able to get routes from one routing protocol into another, hence the term redistribution. You're redistributing routes from point A to point B, or protocol A to protocol B, whether it's OSPF to EIGRP, OSPF to RIP, OSPF to BGP. Depending on which way you're going and what protocol it is, there are certain caveats with each. Now, going back to this, the way that this works now is R5 is exchanging BGP routes with R3. The provider routers, they're running an IGP. So they don't even see BGP. These guys are running straight IGP, which could be OSPF. This guy could be IS to IS. Doesn't matter. It's going to be an IGP. You could run EIGRP or RIP, but why would you? I mean, seriously. EIGRP in the core? Not smart. Just my opinion. I don't know of any provider that's running EIGRP internally. Then again, I don't work for a provider, so who knows. But so that's what you're going to be running here. These routers right here do not know about BGP routes. They are knowing about MPLS routes. So this interface here, this interface here, this interface here, this one, this one, this one, and this one, they're all running MPLS. So you get routes that come in on R5 in VRFA, are redistributed into BGP. They come over here, and they're dropped into R3, BGP. R3 then looks at that, and he actually looks at the route target and the route distinguisher. The route target is what network it belongs to, and route distinguisher makes the route specific to the particular client. I'm not going to get into specifics of what that breaks down on here, but this is the idea behind it. So what you do is you have an import and an export rule for every route target to BGP mapping. You do this so that the route target knows that when traffic comes in from IBGP and it's got a specific route target and route distinguisher information called the BGP extended community value, when that information comes in, then the provider edge router knows to take it out of BGP and put it into the MPLS VRF. The VRF is then what this guy is going to be our VRF aware interface, and then he's going to shoot that information into R7, which happens to be the customer's route. What that basically allows you to do is R7 can advertise this network right here, and this network, let's say there's the loopback right here. He's able to advertise, oh, there's loopback. He's able to advertise those routes into MPLS, and then those routes right here will show up over here in R10's routing table. Pretty straightforward. So if R10 needs to route traffic to R7, he can simply say, oh, when he sends packets to it, he can look at it, he can add stuff to it. The destination will be a route in the routing table already. It's going to be a BGP route. Doesn't have to be BGP, but that's the most common. And he's going to send that route, and it's going to hit the provider edge, hit the other provider edge through the IBGP tunnel. That's what they're commonly referred to as BGP tunnels. And then you're going to drop it off in R3. R3 is then going to move it from BGP into MPLS or VRF, and then he's going to drop it off into R7. Then the same thing works the other way around. So that's the idea behind it. Now that's a high-level overview. There's a little bit more to it than that with how you get all this stuff set up and how many bits are what. That's not what we're here for. What we're here for is the basic underlying understanding of redistribution. So let's talk about that. So let me bring up Paint and let's pull up, and we're going to say, open There we go. It wasn't working. So the idea behind redistribution is taking one routing protocol into another. We've established that. So now what we have to do is we have to go in and we're going to do some command line stuff. So at this point, I'm kind of flying by the seat of my pants. The people that I've invited to this hangout have not shown up yet, so I'm like, I don't know what to cover. So if you are interested in joining a hangout later on and you want to be able to not just view it, you want to be able to participate, send me an email to this email address. That's an A right there. That is gmail.com, by the way. That's my pen pad for you. Running out of room here. Send an email to artriker82@gmail.com, and I will be able to bring you in on these hangouts later on down the road. So that's going to be the benefit for you all to hang out with me. So what I'm going to do is we're going to take a look at this from a higher level overview. So what we're going to do is we're going to take this right here, all these interfaces right here that are facing in the DMVPN network, and we're going to put these guys into BGP. Now you might be saying, well, how do you do that if they're all going to be that? Well, what you're going to do is this guy right here is going to be AS 5810 because routers 5, 8, and 10. We're going to take routers 4, 1, and 6 and put them into AS 416. And then we're going to take routers 7, 3, and 9, put them into AS 379. We're going to run RIP here. We're going to run EIGRP here. And we're going to run OSPF here. So that's what we're going to do. Pretty straightforward. This is going to be, this will be the internet. So what we're going to do is we can peer, we're going to go full mesh. So the best way for me to explain why I drew a big circle is all these interfaces are going to be BGP facing routes. What we're going to do, well, the R2's over here just hanging out. You know what we'll do? Well, actually, we'll extend this down to here. So this will be 3792 is what we're going to do. We'll add router 2 and just for kicks and giggles, just because we can. So the reason for that is because we want to make this a full mesh network. So we want to make sure that everybody can reach everybody else. So the idea generally is when you're dealing with something like this, we'll have 3 separate networks. And let's just assume just for a minute that this is company A. And this is company B. Company B. And this is going to be company C. So now what we'll be able to do is we're going to jump into the command line, and what I'm going to do is bring this down just a bit, and so you guys can see what I'm doing. Super Putty is awesome if you haven't played with it before. It's a great tool. I love it. Anyway, no one cares what I think. I'm just teasing. So first thing we're going to do is on R1. And don't worry about this. This is just some crypto stuff going for DMVPN across the network. So the first thing we want to do is we want to be able to ping, do a show IP route. We're going to look at connected. You could also do, bring this up just a bit here. There we go. Oop. There we go. So we have these routes here. So what we're actually looking at is this is the 155.1 network is the DMVPN cloud because it's tunnel 0. So the first thing we're going to do is we're actually going to go on R1. We're going to do config T. We're going to type in, this is going to be EIGRP. So those of you that are familiar with the CCIE version 5 update, you should know that there's been a change in the way that EIGRP is deployed nowadays. Nowadays, well, I shouldn't say nowadays. What you're going to be tested on would be a better way of putting it. EIGRP now has 2 different ways of implementing it. There is the autonomous system mode, which most people are familiar with, and there's also what they call named mode. And this is the difference. We have router, EIGRP, question mark. You have autonomous system mode, which is obviously by typing router EIGRP1, or you can type in Word. So we're going to say EIGRP comp B. Why that? Because we're going to be in company B. The thing with EIGRP named mode, a virtual instance, what this basically allows you to do is it takes all of the configuration you do for EIGRP and puts it in one section. So rather than you having to configure the routing process or the routing, setting up the networks or the neighbor commands underneath the process for EIGRP under the process, you can, and then having to jump down to the interface level for doing authentication, and then having to jump over to, trying to think what the other place you would do it at. Anything with EIGRP that you would have to do in two places now is under one. So just for kicks and giggles, we're going to use named mode, because I don't know if anybody has seen this, so we're just going to go with this. I've played with this a couple of times. It's actually kind of cool. So let me just show you this. The difference between the two now is you're able to jump in and look at address family, service family, and do some other things with it. So this allows you to run a lot of instances of EIGRP. So first thing we're going to do is we're going to go in and we're going to take a look at, we're going to have to specify the address family we want to talk about. What is an address family? It's simply a forwarding, what type of, if you're going to route IPv4 or IPv6, which protocol you're going to route for. So if you type in address family, you've only got two options, version 4 or version 6. We're going to do IP version 4, question mark. Now this is where it gets a little complicated. Do you use autonomous system mode? Do you use unicast? Do you use VRF? Do you use multicast? Well, in this instance, we're going to use autonomous system mode, and we're going to say EIGRP 100. Pretty common, and if you're going through certification, you're going to see a lot of EIGRP 100. So question mark, and then we can add in numbers if we want to, but that's all we have to do. So now we're under router address family mode. It says route target. I'm sorry. I have, if I do a do show debug, I've got IP routing as my debug on, so that I can see what I'm going through my protocol independent routing section of the CCIE workbooks. I can see when routes get added or removed from the routing table. This is how that works. So first thing we're going to do is we're going to do a question mark, and we have quite a few options here. We're going to look at, we have, adjust that just down just a bit. Beautiful. So we have address family interface, we have EIGRP, default commands, we have neighbor, network, timers, topology, things like that. So I'm not going to, this isn't a walkthrough of how EIGRP works. There will be one in a lot of detail once we get to EIGRP for CCIE version 5. If you're following me on my YouTube channel, definitely go check that out. It's something you guys will definitely want to check out and have set up. But what we're going to do now is we're going to type in network, and we're going to say, what's the network number? We're going to type in 155.1.146.0, 0.0.0.255. So we want to specify out this interface. Now, the difference between named mode and autonomous system mode is that when we're dealing with a named mode, we don't have to physically match like we did in autonomous system mode. We're still going to do that so that people that are familiar with the IGRP and the autonomous system style won't get confused in this part. So we're just going to hit enter there. Now, if I want to go to AF interface and I want to type in gig 1/0.146 question mark, hit enter and do a question mark. Now, if I wanted to do anything that was at the interface level, so if I wanted to modify the bandwidth percentage, dampening, and next top self, I'm going to run DMVPN, whatever the case might be, this is where you would do that on the address or the address family interface. I'm going to exit out of here. I'm going to go back to this guy, and I'm going to show you what topology looks like, what the topology is actually trying to do. So we have topology, topology base, question mark, enter, and from here we have all of our redistribution and stuff like that. So under named mode, this is where this is going to be. So if you want to do any type of distribute list, you want to modify a maximum path, things like that, this is all going to be underneath the topology, which is going to be located underneath the routing process if you were in normal autonomous system mode. So we're going to exit that as well. So right now all we have is we have our network set up. So we're going to do that. Now that's set up. We do show IP protocols. Right now we have EIGRP 100, and that is it. So that's all we have going on for right now. So what we're going to do now is we're going to go to router 4 and router 6 and repeat the process. We're going to go to global config. We're going to type in router EIGRP. What do I name this one? Comp B. Is that what I named it? I forgot what I named it. Yes, I did. EIGRP Comp B. Okay, cool. B and capital B. So we're going to type in now is we're going to say address family IPv4. We're going to type, and we're going to say autonomous system mode, autonomous system 100. Then we're going to type in network 155.1.146.0, 0.0.0.255. And we're going to hit enter. So now we should have a routing adjacency pop up. So that means that it's working. So do show IP protocols, and we have that. If I do show IP route EIGRP, we don't have anything in there yet because we're not advertising anything. So once we get there, we will. But so on R6, we're going to do the exact same thing. So if you ever want to copy and paste, here's a good way to do it. Do show run section router EIGRP. Hit enter, give it a second to propagate, and type this information in right here. Copy this, and go to router 6, and do the same thing. Whop, bam, boom, there you have your adjacencies. Easy peasy lemon squeezy, right? Well, that's a great thing. So now what we're going to do is if we do show IP route EIGRP, we're still not learning anything. Well, why is that? Well, simple. Because of the fact that we haven't advertised anything in. So what we're also going to do is from R1, we're going to say, because we are using the loopback, that's our router ID, we're using 155. So what we're going to do is we're going to create a loopback. We're going to exit out of here. There's actually going to be two exits, out of the address family and then out of the router configuration mode. Then we're going to type in interface loopback 100. We're going to type in 1.1.1.1, and or you're thinking to yourself, IP address, buddy. 1.1.1.1 and 32-bit mask. So now we're going to go back to router configuration mode. We're going to type in, and don't worry about this stuff. This is just the routing table telling me that it's added the loopback to the routing table because it's a connected route. So we're going to type in router EIGRP comp B, and we're going to type in address family IPv4, and we're going to type IPv4 autonomous system 100. A lot of extra commands in here, but it just I'm doing this now so you guys can see it rather than being confused later on down the road. So now what we're going to do is we're going to type in network. We're going to type in 1.1.1.1 0.0.0.0 because I only want to advertise that interface. Okay, so we hit enter, bam, and now if we come over here to R4 and we do show IP route EIGRP, we have the one network in there, and it's a D route, so it's being advertised, and R6 should learn that as well. And voila. Pretty straightforward. Now we're still on R4, we're still here, so we're actually going to do network. So we're going to type in network. We're going to type in 4.4.4.4 and 0.0.0.0. Oop, one too many zeros. That, and we'll do the same thing for R6, and then we'll just create the loopback. The route won't actually go into the routing table until the interface is configured, as you can see. So we'll come over here, this guy, address family, IPv4, autonomous system 100, and we'll type in network 6.6.6.6 and all zeros. We're gonna exit out of here, or let's do end and then config T. What's the difference? So we're gonna type in interface loop 100, and we're gonna give it IP address. It's gonna be 6.6.6 and 32-bit mask. And there we go. And that adds it to it. Voila. And we're going to do the same thing here. We're going to exit, and we're going to type in interface interface loop 100, and IP address is going to be 4.4.4.4 and 32-bit address, or mask, I should say. And so now we come over here to R6 and we do a show IP EIGRP route, and we have the routes propagating. So we know routing is working. At least layer 3 IGP is working. So we're going to jump over to what is that? R7, R8. Oh, let me bring this over here just a bit, just so I can see what I'm doing. So we're going to jump over to R2, and we're going to do, again, don't mind that. This is all going to be RIP. So we're going to go global config, we're type in router RIP, everybody's favorite routing protocol, version 2, and no auto. Now, the one thing about newer the new iOS 15 do show IP protocols. By default, interesting. Did RIP not take? That was unexpected. So it might be because I don't have anything configured yet. We'll type in network, and we're going to type in, we'll type in 155.1.23. Or actually 155, that's it. That's 0, and that's it. So do a show IP protocols. Okay, there it is. By default, automatic summarization in iOS 15.2 and above. Now, if we do show over include iOS, I'm running 15.2, Advanced Enterprise Services. Automatic summarization is no longer automatically enabled. So auto summary is turned off by default in RIP. So you can go ahead and not have to worry about the auto summary and just force a habit, really. But it's good to have that command in there. So we have that now, and then we're going to jump over to R3 and get that configured. And that's all we have to do. And actually, let's do this. We'll type in interface, or I'm sorry, network. And we're typing 150.1.0.0 because we want to advertise the loopback address. And then we're going to do show IP protocols again. And now we're advertising the loopback, and we're advertising the directly connected interface between router 3 and router 2. Jump over to router 3. Router RIP version 2. The version changes do have an effect because of the fact of there's two different versions of RIP: a broadcast or class full version, which doesn't advertise the subnet mask, and the classless version 2, which does advertise the subnet mask. It supports authentication and summarization and variable length submasks and all other good stuff to go along with it. So what we're going to do now is we're going to type in network 155.1.0.0 and as well as .0. So if we do show IP route RIP, and there's the RIP route from router 2. So we're receiving the route in from there. So that's good. We're going to jump over to router 9, or I'm sorry, router 7 first. Config T, and well, I just looked over. I have 2 viewers. Very cool. Thanks for showing up. We're going to do router RIP version 2. Network is going to be 155.1.0.0 and 150. This guy. So that's all we have to do there. And then what we're going to do is we're going to jump down to router 9 and do show IP route RIP. Router 7 should be interesting. Why is that not coming across? Oh, there, it scared me. There was no updates. But I have to remember that RIP is every 30 seconds. So there we go. We have some routes coming in. That's a great thing. Now we're going to jump over to router 9. Same thing, config T, router RIP. We're typing version 2. And we're typing network 155.1.0.0 and 150.1.0.0. So that's what we have there. Everything's set. So now if we type in do show IP, and you're going to find a lot. Whenever I configure something, I usually always jump down or check to see if there's been an effect on that command. I'm like been hard coded to do verification after everything I do, because I don't want to get 10, 15 commands in, or 10, 15 different things that I've implemented, and then do a show command, show something for the very first thing I did, and it's not there, and I'm going, oh crap, which command did it? So by doing it after every command, you are reassuring yourself that what you're doing is actually having an effect and working. So do show IP route rip. Do show. And voila, there we have it. So now what we're going to do, we're going to jump over to, can we drag this up over here and scroll up just a bit? There we go. We're going to jump over to router 5, 8, and 10. So now what we're going to do is we're going to do router 5 and go config T and type in router OSPF. And notice how if we hit tab, it stays at the end of the F. Question is, why does it do that? Because we could do both version 2 or version 3 for IPv4 or IPv6. Some key differences here. Remember, version 3 is specifically for IPv6, but there's been some caveats with that in iOS that I've been seeing. So I'll cover those in more detail in an upcoming video because I don't have time to really do it here. I wanted to speed this up a bit and actually get into the actual redistribution part, because that's where I think is going to be the majority of our time. So we're going to do OSPF version, and then we have 1. Now, if I do version 3, question mark, I can still give it a process ID. So I can still run version 6, but we're going to give it version 1. Question mark. Now let's bring this down just a bit here. There's going to be a lot more options here than in the other two protocols. And I don't have much more room to work with. We have address family mode, and then we have the network commands that are down here, stuff like that. I'm kind of partial to address family mode. The reason for that is because of the fact of studying for my CCIE, that's what we're kind of going to have to be going to anyway, because version 5 CCIE, there's IPv6 and IPv4 that's going to be implemented at the exact same time. That's why you see the addressing the way it is, because of the fact of what's going on. We have both version 4 and version 6 IP addressing throughout the entire network. So what I'm going to type in is I'm going to say network, and I'm going to say 155.1.0.0, and I want to just capture everything, and 0.0.0 255.255, and what command? Area 0. Thanks for participating. And we're going to do 150.1, and that should be that. So now what we're going to do is do show IP protocols, make sure that OSPF is actually running, and it is. The two routes are being advertised. So now we're going to jump over to router 8 and 10, config T, router OSPF 1, network 155.1.0.0, .255.255 area 0, and you are correct. I'll explain the first router as I'm going through piece by piece, and then I'll speed up the configuration as I go through the rest of them. Simply for the fact that you don't need to hear the same thing 3 times. Router OSPF 1, network 155.1.0.0, 0.0.255.255. If you don't understand what the 0.0.255.255 is, that is a wildcard mask, meaning that this right here needs to match. These right here are indicative of what's advertised here. The 255s mean I don't care. It can be anything inside of this range. So we're going to hit the up arrow and go over here and that. So next thing I have is do show IP route. Am I learning any OSPF routes? I am not, which is actually kind of bothering me because I should have already learned. Oh, there we go. It's taking a little bit longer to propagate than I was hoping. And drop down out of here and show IP route. We have some OSPF routes. And oh, there it goes. And do show IP route. We have some OSPF routes. Beautiful. Okay, now that we have IGP up and running, and that was actually pretty quick in the grand scheme of things. So now let me pull this guy down here. Now let's get into the juicy part. BGP. If you don't know BGP, I'm going to explain BGP from a high-level review real quick, and then we're going to get into the configuration. So I'm going to drop this down right here, and we're going to go back to a little discussion because we have routing updates going back and forth and all that good stuff. BGP is a TCP based connection. Okay, think of it more of an application, and that it doesn't actually have an IP protocol like OSPF or EIGRP, where EIGRP is protocol 88 and OSPF is 89. They have their own IP protocols. So that's how they're able to do all of what they do very, very well. BGP, on the other hand, does not have a IP protocol. It sources traffic, or I'm sorry, it sends traffic to TCP port 179. There's a pretty in-depth way of looking at how TCP or BGP works from a high-level overview. But what it basically does, if you're not familiar with it, is it will simply, and always has been, it'll be able for you to bring routes from this network, and this network to be able to be seen by the other networks. Pretty straightforward when you think about it, but some people don't understand how that works. So here's what we're going to do. It's going to be easier if I show you what to do. Everything's based on the autonomous system mode. So actually, let's give it this autonomous system. Oh, I've already given the autonomous system mode. We're going to start over here in AS5810, and we're going to say, and exit out of here. We're going to say router BGP 5810. We're going to say neighbor, and we have to form the adjacency between R4 and R5 and R5 and R1 and R5 and R3 and R5 and R2. So we're going to have to do 5 separate remote neighbor commands. But the nice thing about it is once you have one in there, they're pretty easy just to go in there and tweak them. So we're going to type in neighbor and the directly connected neighbor IP address. So it's going to be 155.1.0.4. Remote AS is going to be 416. Okay. Now what's going to end up happening is R5 is going to try to send BGP connect messages to R4, but R4 is going to drop them because it's not listening for BGP. We're going to do the same thing here. We're just going to do neighbor R.3, and we're going to say this guy is going to be, what did I say his was going to be? I forgot already. 3792. So we're going to say 3792. We're going to do that, and then that we're going to do R1 as well, and R2. So we're going to do R2 first, and do that, and then we're going to do R1 as well. All right, so that's what we're doing. So if we were to debug BGP, you would see this. So now what we're going to do is we're going to jump over to R4, and we're going to do exit out of here. We're going to do router BGP 416, and we're going to type in router BGP 416. Type in neighbor is going to be 155.1.0.5, and remote AS is going to be 5872, right? 5812, 5810. What did I type in over here? Router 5. What router was I on? You guys are probably screaming at me. You're typing in R4. No. R5? Oh, hold on. R10? Oh, that's what the problem was. So exit out of here. No. Actually, let's do show run section router. I goofed. Router BGP. You guys are probably going, no, you're putting it on the wrong router. Thanks for giving me a heads up. So we're just going to copy and paste this information and R5, and we're going to exit out of here, and we're just going to go bam. And then what we're going to do here is we're going to go back to R10, and we're going to type in no router BGP. um, 5810, and there we have it. So that's that. So now that we have it taken care of, and we're going to go back to R5, and we have that set up. So now what we're going to do is we're going to go to R4, and we have it's going to be 5810. And what's going to end up happening now is there's going to be a BGP neighbor relationship that's going to form between R4 and R5. We're going to same thing on R3, and we're going to do this guy right here, and R3, and we're going to say exit router BGP. That's going to be forgot again 3792. 3792, and we're going to just copy and paste that in there. Incomplete commit remote AS is going to be 5810. Hit enter, and voila. Copy that in, go down to R2, exit out of here, router. Do I have to exit? No. I just choose to. BGP 3792. And then we're going to just copy this in here and be done with that, and then R1 is the same. So I'm going to type in router BGP 416 and just copy and paste. So that's how we have that. And then we'll go back to R4. We should have a neighbor relationship, and we do. We have BGP right there. BGP did form. So now if we do show IP BGP, we're not going to have any actual routes in BGP, but if I do a show IP BGP summary, we're going to have a neighbor connection over to router 5. So now what we got to do is, now that we have all these routers connected, one side step before I actually get into actually how to redistribute traffic into routes from BGP into the routing protocol is this. Right now, R4 and R1 are on the same, or they're in the same autonomous system number. What I could do between R4 and R5, or I'm sorry, R4 and R1, is I could form an IBGP TCP tunnel and make this IBGP, and they could be exchanging routes. So if this guy goes down, R4 will still be able to leave the network, or traffic from AS416 will still be able to leave the network. But what I'm actually going to do is I'm going to form a route reflector configuration, I was trying to think of the word, from R1 and R4 to R6. Route reflector simply means that I don't have to have a full mesh of connectivity between all of my internal IGP routers. So that's what we're going to do. So then what we're going to do is we're going to set up, I lost my thing here. Lost my train of thought. We're going to set that up, and then we're going to be able to get routes redistributing. So now, here's where the common misconception understands. So we're on R4, but I'm going to go to router 5 first. We go to router 5. Here's where the common problem comes in. I can advertise routes two different ways into BGP. I can type in the network command, network, and it's got to match something that's in the network. So whatever I have physically configured on the interface is how I need to advertise it to BGP. So 155.1.5.0 mask 255.255.255.0. If I wanted to advertise in this particular route into BGP from OSPF, then I would have to type it in like that. But I'm not going to use the network command to do this. I'm going to use redistribution. And I'm going to show you what that looks like. I'm going to actually just control U here. I'm going to say, we're going to go to redistribute OSPF 1, question mark, and I'm going to say, I should just have to redistribution match, and this is where it gets kind of confusing. So do I match internal? Do I match external? Do I match NSSA external, which is not so stubby area? Well, by default, it matches internal only. Why internal only? Because external OSPF routes mean that OSPF is receiving routes from another protocol, whether it be another BGP router, or it's receiving BGP routes in and then advertising them back into BGP, which can form a loop. We have EIGRP to OSPF and then advertise those into BGP. We don't want to do that. We want to just type in internal. That's all we want to do. And then we're going to do router OSPF 1. We're typing redistribute BGP question mark, We're going to say, what's the autonomous system number? We're in 5810, question mark. And we're going to say we want to give it a subnet. Subnets. Now here's one little kicker that most people don't realize. You can actually go in there and modify the metric. So you can give it a seed metric that it's going to be applying to. You could modify the type or the metric type so that depending on the situation, you can go in and you can modify whether the OSPF cost increments as it goes through the network or it doesn't increment. Doesn't matter. So we're just going to do redistribute OSPF routes. So right now we just have that going on. So if we were to type in do show IP BGP, now we have a whole bunch of routes. Some of them are from, these are all from router 5 is advertising these guys in. And notice how they have 0 means the local router or router 5. This guy right here means it's going to be the network coming between router 5 and router 8. So now what we're going to do is we're actually going to jump over to router 4. That's EIGRP over there. We're going to type in router EIGRP, exit out of here, router EIGRP company B. And we're going to type in address family, IPv4 autonomous system, IPv4 autonomous system 100. And we're going to type in, we want to go in here to topology, a base, and we want to redistribute. So we're going to redistribute BGP, autonomous system 416, question mark. Now we have to specify a metric. So metric, and we're going to specify what the metric is. We're just going to say, we're going to give it 10,000. These numbers are just arbitrary. They don't really matter. 10,000. We can do 250, question mark. This is going to be, it's 100% reliable. It's 255. The load is going to be 1. And we're going to have the MTU is going to be 1500. Because these are all Ethernet connections. So we're going to have that. Now we're going to go to router BGP 416. We're going to redistribute EIGRP 100, question mark, and we're going to give it a metric. We actually don't have to give it a metric. So let's check to see if we're receiving any routes. Do show IP route. And we are. We are actually receiving quite a few routes. And if you look right here, we have a B route, which we're learning 155.1.108, which, where is that coming from? Right here. That's this network right down here. So router 4 is learning in this network right here. So that's a good sign. So now if we were to do show IP route BGP, we're learning quite a few routes, actually 7, 8 of them. So that's how you would see that. If we do a show IP BGP, or do show IP BGP, then we're going to get a bunch of routes. And then we have these routes that are put in here. So this is the route from router 5 that we learned in. Now here's the kicker. See this R right here? Any idea what that actually is? What that means is, this is what they call a, what do they refer to it as? Rib failure. Sorry, I had to think about it. Rib failure means that there is a better administrative distance to get to that network than what iBGP or eBGP has. Meaning, it's directly connected. Doesn't need BGP to get there. So that's what that rib failure means. So that's that. Now we're going to go to R3, and we're going to type in exit. We're going to type in router rip, and we're going to type in redistribute, question mark, and we're going to say BGP 3792. I always have to think about that one. 3792, question mark, and we're going to say, what do we want to do with it? Do we want to give it a metric? Well, let me explain why you would want to give it a metric. There's two different ways you can do it. You can do a default metric, which is going to advertise it to the entire autonomous system no matter what, or you can use transparent. When you use transparent, that means whatever R5 advertised into R3, whatever that metric was, it actually does carry from R5's BGP network over to R3. So you can type in transparent, but we're going to give it a seed metric of 5. That's all we have to do. Type in router BGP 3792. We're going to type in redistribute RIP question mark, and then that's it. So that's all we have to do there. And then we're going to go down to let's do a do show run section router BGP and RIP. Am I going to get hammered for that one? No, I won't. So now we have the redistribute commands right there. So what I'm actually going to do is I'm going to take this command right here. I don't have to actually take that. So we're going to take, and we're going to jump over to R4 just to verify, or let's go R1, it's directly connected to router 3. We're going to do show IP route BGP. And I'm learning routes in. And I'm learning 37. Is 37 in there? It most certainly is. So I'm learning those routes in from BGP. So that is R3's directly connected interface to router 7. So that route is being advertised, which is a good sign, because that means redistribution is working as it's just supposed to be. So that is the thing with that some people have an issue with, is how redistribution actually works. So now, here's where we get into a little more complicated stuff. We're going to jump over to R2, or let's go to R3 real quick, and metric 5, and we have redistribute. Okay, I want to make sure I have all my eggs in one basket here. Router RIP. We're going to type in redistribute. BGP metric is 5. BGP 3792 metric is 5. Type in router BGP 3792, and we're going to type in redistribute RIP. Bam. That's all it should be there. And now we're going to go over to, did we get 1 in? I don't remember doing that. We do have it, but I didn't configure it. Right? Do show IP protocols. I don't see it redistributing anything. Yeah, I don't see it doing it, so I don't think I've do show run section EIGR or router EIGRP. I don't think I've actually done it on this guy yet, and I haven't. BGP. I did not. So we're going to go to router EIGRP. Actually, let's do this. Let's go to R4 and do show run section router. I can just type that in and it's going to give me the output of both. So we're just going to copy and paste this information in right here. So we're going to redistribute RIP and redistribute BGP and that, and then we're going to do redistribute EIGRP 100. So R1, and we're going to do, we're under BGP, right? Router BGP 416. We're just going to redistribute, or no. Redistribute EIGRP 100 and router EIGRP company B, right? Yep. And then we're going to jump down and we're going to do that. Voila. Oh, I know. Go for it. Figure. Control A goes to the beginning of the line. You can do a shift 1 is going to give you a exclamation point, and we can go to E, and then we're going to hit enter. That saves the config so we don't lose it. We're going to type in address family IPv4 autonomous system 100, and then we're going to hit the up arrow and Control A, erase that, enter. Oh, duh. That's my fault. Topology base, and we're going to hit the up arrow, and there. We have to go underneath the topology information. So now, as you can see, the routing table is updating. We're bringing all these routes in that we didn't have before. So that's a great sign. So now here's the kicker. let's go to R10, and we're going to do a do show IP route. So we have all these external routes, right? We have a lot of external routes. So right now we have full reachability in our network, and that's the key thing. We have to have full reachability. So what I want to do is I actually want to trace to, drop out of here, trace to 150.1.6.6, which is going to be R6's loopback. Let's see how far I can get. Oh, we have a loop. Sure do. We hit 79.9. Where is that? 79. Oh, we're all way over here. We have a loop. Yep, we have a loop, ladies and gentlemen. So let's let that finish out, and it's done after this one. So it's going between router 7 and router 9. So even though we have full reachability, okay. So now let's scroll up here and take a look at what we hit router 3. That's not where we wanted to go though. Router 3. Why would we want to go to router 3? That's not good. Went to router 3, but it doesn't know how to reach router 6. Technically speaking, it does, because it dropped it down here. For some reason, we went that way. So now we have an issue. Even though we have full reachability, everything's showing up in the routing table. Okay, so now, depending on the exam you're in or the real-life situation you have, how do you fix this? Oh, crap. Can you get these routes to here? Sure, no problem. We run into the problem of, okay, how do we fix this? Well, I'll tell you, there's a couple different ways. You can configure a distribute list here. And what that would do is you could say deny, and you could deny specific routes coming from that are, how specific do you want it to be? You could deny routes in that are coming from, that's kind of difficult to do because it still can be done because we're advertising the redistributed routes. 150.1.6.0, I believe that's one thing we could do. Or what we could do, actually the easier of the things to do would be to set up a distribute list and say that the destination would not be to here. We could route it this way. Now, what I'm going to do is I'm going to go to router 5 and see where the BGP next hop is, because realistically, the way that this stuff actually works is R5 could be saying that R3 is a better route. The BGP path selection process could be goofing us up. So just depends on the situation. So what I'm going to do is I'm going to go to R5. I'm going to do a end out of here. I'm going to do a show IP BGP. This is going to tell me what routes are preferred over what. So we have, let's see here, 108. 3792, that's where they're going to go. They're going to go this direction. So the way that we actually break this down is we want to see where, and it's not getting, let's see, 6.6. I don't even see 150.6.6 in here. Oh, that might be why. It doesn't know it. It doesn't know that route. But it does know this guy. It knows this route right here. And because this guy right here is the, what do you call it? The best path, because anything with, how does it work right here? This is, a star means valid. A right caret means best. So what it's doing is saying, the route to router 2 is a valid path, but the route to router 3 is the best path, so I'll send it that direction. So that's what the problem is. So we're going to go to R10 and we're going to do a trace route to 6.6.6.6. Let's see see where that goes. Router 4, and there it goes. So the problem was the way that we were advertising the route into router 5 is that router 5 is learning that route, and it's saying that the best way to get there is to router 3. Router 3, once it hands it off to router 7 doesn't know what to do with it. So router 7 hands it to 9 hands it back to 7, and so we get this loop. So that's one thing you could see. It's how common in a bad design vary. In a good design, if you know what you're doing, you can actually get it. So let's jump over to router 3 and see what his stuff shows up as. So show IP BGP. So 150. See, we're not learning that route because we advertised it as 6.6.6.6 from router 6. It's learning that route in as 6.6.6.6 from router 5 or from router 4. So that's where it's advertising it in from, and that's on router 3. Even though we have the route from router 1 here, we could go router 1, but what's the best way to do this? What's a good way to get this to happen? Well, what you could do is on router 1, let's go to router BGP. Router BGP, had a brain fart there for 416. You could type in neighbor. You could type in neighbor, and you could type in 155.1.0.5, and you can say next hop self. Now, is that going to fix it? Let's test this. Nope. Still bouncing. Control-Shift-6 to break out of that. What about 6.6.6? No problem. Goes to router 4. Bam, it's there. So the issue that we run into is if the route is not advertised correctly by the router that's needing to get there, then we run into a problem. So the best thing to do is on R1, because router 1 is the closest one to it, is what we could do. The other thing too is we look at here, show IP BGP for 150.1.0.0/16, I think it is. We're learning it from router 2 and router 3. Okay, that's our number one problem, is we don't actually have a we're learning it the wrong direction. So if I wanted to go in here and I wanted to manipulate this somehow, how would I do that? Well, I could make it a longer match. That would work. I can go to router 1 and manipulate this and say, I want to create a route map or a distribute list that says to advertise a longer match to BGP. I could do that. That'd probably be about the best way to do it. But if we were to go to R6 and we were to go to exit out of here and type in run EIGRP, so we were to type in router BGP 416, and we type in network 155 or 150.1.6.0, and mask is going to be 255.255.255.0. Now if we were to come over here to R5 and then do a show IPGP for, let's do show IPBGP. See, are we learning anything more specific in? Not yet. Let's do a clear IPBGP, and we're going to do we're going to do star just for the kicks and giggles, star, and hit enter. That's going to bounce all the BGP neighbors. It's actually going to cause a triggered update, and 3, 1, 4, 3, and 2 should be up here in a minute. So what we're going to do is show IPBGP, and we're going to see if we're learning that route in now. I don't see it yet. I see router 10, router 5. I've got 6 here. So let's do that trace again. Oh, actually, it's router 5. I want to do router 10. Router 2 to router 3 to router 7 to router 9. Byte to 7, byte to 9. Yep, still not working. So, best way for us to do this. Let's see here. What's a good way to fix this? I'm trying to think here. What's a good way to do this? I don't have all the answers off the top of my head. I have a good portion of them, but not all of them. We have an issue here, and we need to figure out what that issue, how to fix that issue. So, you know what the part of the problem is? We're on R6, and if we drop out of here and we do a show IP BGP, we're not running BGP here, but we're running. Where did I do that? R1. What? Okay, so I don't. Okay. Let's take a peek here, and we're gonna do a show IP BGP. We're not even learning it from here. So what we're gonna do is we're gonna go on R6, and we're gonna go. That's part of our problem too. We're gonna go to config T, and we're gonna type in router BGP 416, and then what we're gonna do is we're gonna type in neighbor is gonna be 155.1.146.1. We're gonna say remote AS is gonna be me. Or remote AS is going to be router 1, 416. The same thing for router 4. We're going to peer with those guys. What we're going to do on R4 is we're going to type in router BGP 416. We're going to type in route, that's not the config I wanted. Neighbor 155.1.146.6 is going to be remote route reflector client. Reflector client. Oh, that's right. Remote AS is going to be 416, and then the route reflector client. Same thing over here on our R1. And we're going to do config T. We're going to type in router BGP 416. Neighbor is going to be 155.1.146.4. Remote AS is going to be 416. We're going to peer with one way here. And we're going to do router 6. Did I do that on router 4? Yes. And then that, and then we're going to type in route reflector client. So now if we go to R5 and we do a, oh, we just cleared it. So we should be getting an update here in a second. And okay, cool. So that's what we have now. Now we're going to do a show IP BGP. All right, we're still not learning that route in though. So now what we're going to do is we're going to go to router 6 and we're going to type in router BGP 416. We're going to type in network is going to be 150.1.6.0 mask 255.255.255.0. We're going to go over here to router, and we have an update there. We're going to go to R4 and do a show IP BGP. Show IP or clear IP BGP, but we're going to do this for autonomous system is going to be 416 soft. We don't actually want to drop the neighbor relationship. We just simply want to what's the term I'm looking for? We want just to relearn the routes. So show IP BGP. You know, that may not have taken. So let's go to router 6 here and show IP EIGRP interfaces. loopback 1. So it's on the loopback. So let's see here. We're going to say show on R6, or I'm sorry, R1. We drop out of here and do a show IP EIGRP topology. Am I learning 150? It may come down to a longer match issue because the longer match is the /32. So can I ping 155 or I'm sorry, 150.1.6.6? And I can. So I can ping that. Can R5 ping it? Ping 155 or 150.1.6.6? No, he can't because he doesn't see it. Can I ping 6.6.6.6? No, he can't. Do I see show IP route BGP? He does see it, but he doesn't have he can't ping it? Okay. Let's source it off of loopback 0. Does that make a difference? Ha ha, there's our problem. Okay. Can we ping that? Can we ping this and source it off the loopback? Nope, still can't do that. All right, so basically what we have a problem with now is actually, let me come over here and I bet you I'm the only viewer. Interesting. Okay. Sorry, I had to look at something real quick. All right. Thought I took care of that, but I guess not. So I guess that's just a minor issue, and I don't want to spend a ton of time working on that. But the one thing that we have a problem with is, and I apologize for having to stop and do something. I had to take care of something for work real quick. Is we run into issues with the way that we can get into loops, and you've already actually seen that. Let me bring up a new page. Might take it a second to pull up. There we go. So the problem we run into when we come to this is we run into issues where we have R4 and R5, or R1 and R4, and then we have R3 and R2, are both connected to the same EIGRP domains, right? So the problem we run into, and we don't have to worry about that because R5 is a single point, so we have two-way redistribution working. The problem that we often run into is we have R1 and R4 goes through and we're advertising the same routes. So the most common way to do redistribution is to do it the way that I did. It's the simplest way to do it. Now, the problem with that is if we have routes coming in here, and then we have routes coming in here, do you think that we might run into a situation where we could have a loop based on that? Well, absolutely. And why would that be? Simply for the fact that we have R4 learning routes from that R5 is advertising to it, and that R7 is learning, or I'm sorry, R1 is learning back in from R4. Now with BGP, what actually happens is the autonomous system number, so 416, is actually coded into the update as a tag. And what ends up happening here is R4 advertises that out with 416 in the as a tag value. R1 learns that in, and he's able to see that and go, oh, well, if he receives a routing update in from R1, or I'm sorry, from R4, he's going to see that and know that that is a redistributed route back into him from a router that's in the same autonomous system as him. So therefore, I should drop that packet. So the most common way to deal with situations like this is to go through and set up a route map and set up tags and match addresses and go in there and delete tags or match a tag and drop it if you see it. It's a little tedious, but it's usually the only way to do it. So what you would do is you would create a route map, and a route map is just a combination of if-then statements. So we're going to say if X matches, then set X parameter. That's the idea behind a route map. And you can have many sequence numbers. By default, it starts off with 10, and it's a permit. When it comes to if statements, you can, if you have a access list matches a prefix, then you set the next hop info, which could be the next hop IP address, whatever the case might be. In this case, you can set the tag to say 200, and then you can create another route map that is going to, or in the same route map, it doesn't really make a difference. You can set the same route map with a lower number sequence number, say sequence 1, and you can match tag, say 20 pipe, which is going to be and or 30 pipe 100 pipe 200, or whatever the case might be, and then you would set as a drop. And that's what you would do. You would match it and you would set it and it would drop the tag or deny. So you could do these things, and the idea behind them is to prevent loops in your network. This is going to happen when you have multiple points of redistribution in your network, and you need a way to prevent routes from propagating to places where they don't belong. So the most common thing for people to do is to get in and do a route map with redistribution. And the way you would do that is you would simply go on R4, you would come in here and you would type in config T, type in route dash map, and you would say the name of the route map would be redistrib, and you say sequence number 10 and permit. You would say $10 and question mark. Oh, permit 10. Sorry. And you would say, and you could do deny 1, and it would deny it. And then you would type in here, and you would say question mark, and you say it would match. And you could match whatever you want. So match tag, and then you could say 200, 255, question mark, and you could say 210 or 220, and then you would hit that. And what it would do is once you would apply the route map, is it would deny those routes from being learned in. You could also do this for outgoing routes as well. You can do it for inbound traffic and for outbound traffic. So as long as it's being applied, and you could apply this to a network command, it can attach this to a neighbor command. Doesn't really make much of a difference, but that's the most common thing. Now, most people ask, how does it know what to do? Well, let's talk about that for a minute. The way that it actually knows what to do is because of the fact that iOS looks at it from a let's change the size to this and the color to red. So we have a situation where we have iOS, when you redistribute, looks at routes in the routing table. Routing table. And routes that are connected. That is what it does to look at it. It sees that, then it's able to go in there and manipulate whatever it needs to manipulate. By default, routes in the routing table are looked at, not in the database, but the routing table. It has to be candidate for routing before it can be candidate for redistribution. So once that applies, so if you look in the routing table, show IP route, any of those routes are candidate. If it's not in the routing table, it's not candidate to be in there. So that's the idea. Now, if you type in router or type in network 0.0.0.0 and all 255s, what's going to end up happening is that's going to match all routes, meaning everything that you have is going to be advertised into the routing table and also is candidate for redistribution. If you do a network 255.255.255.255, all zeros, this would be OSPF. This is the IGRP. Okay, that's the fundamental difference in how you would advertise all routes. So you could do that and then set up a route map, a route map, and then with the route map, you could go in and you could say that if when you set up your redistribution. So this would be the actual network advertisement, net advertisement. Would be this guy right here, and then you can go in and you can simply add in and you could say for the redistribution statements, you could say redistribute protocol, whatever the protocol is, and then you could say, and you want to match a route map. So you would simply go into the command line and you would do this. You would type in, let's type in exit out of here, type in router BGP 416. I haven't set up a route map yet, but you can type in redistribute RIP question mark, and you can type in route map, the name of the route map, which in this case is going to be redistribute question mark, and then you can set the metric. So whatever the metric is going to be for that, and you can type, and the default metric is going to be, say, 200 question mark, and that would be the command. You type that in, and then traffic based on whatever parameters you set in the route map would be triggered by the route map, and then potentially redistributed, potentially not. Tags could be added in and stuff like that. So the idea is to make it very, very simple to go in and add routes in and take routes out. Pretty straightforward. So beyond that, that is pretty much how redistribution works. The quirks behind that are when you have issues where you're trying to get to a network that isn't being advertised. So you could go in and advertise a better network if you'd like, or not. Just depends on how you want to work it. So that's pretty much what I wanted to cover. It's one of those things where once you have things operational, it's more difficult to do it, try to figure out what happened before you plan it. So my best advice to you is if you want to know more about this stuff is to go in there and really understand what's going on. So understand redistribution, understand how it actually operates, and play with it. I mean, I've played with this stuff for several hundred hours, so it's something I feel pretty confident doing. I can make stuff redistribute. I can get routes to propagate. All that type of stuff is great. So it's up to you how you want it to do it. So I'd like to thank you for watching this Google Hangout live. I will continue to do these. Except for the next time I'm going to do this, I'm going to set up a little bit differently to where it's more of a hangout, not a live broadcast, to where I can get more viewers and people to actually interact, so that where there's actually questions and stuff like that. So any questions, feel free to drop me a line on YouTube or my watch the channel trailer that I have. I hope this has been informative for you. I'd like to thank you for viewing.